All right, this is Coach Jay here. This is section 6.1b. Right now I have 6 people in my AP Stats class, 5th period. So thanks for showing up, everybody. And all of you that are watching this at home right now this weekend, you would never skip school, would you, for Grandparents' Day? And so I know that you all are all sick.
Yeah, call them out, Coach Jay.
The probability of that happening, since it's an independent event, would be very unlikely. So I think that's statistically significant. So liars is what I gotta say. Liars. Okay, so let's talk about this. Just a few things. A lot of this stuff is review. Remember we talked the other day about at 6.1a. We talked about like this thing here. That this like chart was called a what? Do we remember? I think it's called a probability distribution. I think I got that word right. Right? Probability distribution. And we talked about randomness a little bit. We talked about discrete, and we talked about continuous random variables, right? And remember we talked about how discrete was more or less what a probability distribution was. If you think about it, we're talking about specific values that don't have gaps in between, right? We think about the amount of shoes that you own, right? That is concrete. You can't have 1.5 shoes. Well, I'm sure there's a way, but we're just going to say there are gaps in the middle of that, right? And we said that if we have a continuous random variable, that would look more or less like a normal distribution curve, right? What we talked about with the 68, 95, and 99.7. The continuous random variables you're going to look at home, or maybe you are at home right now and you will look at that later on. But the actual sheet that I gave you, that's what you're going to kind of go back to, is this idea of normal distribution and that continuous random variable. Okay, so that's kind of the idea here. So this we have not looked at. When we talk about discrete random variables, this is how we would describe it in a probability distribution. Okay, table there. Okay. So let's just do this. Let's just remind ourselves, though, if I were to give 5 numbers, how would I find the mean of that?
Add them up and divide by 5.
Yeah, that's right. So, and I want to make sure I got the variable right. So we got x bar equals, okay? And if you remember, I'm going to get the formula like officially right. Remember, it's the summation of x, right? Right. So we add all of them up, and then we divide by the total of n, right? So that's pretty simple. We do 4 plus 9 plus 10 plus 12 plus 15. We add all those up together. We get 50, right? We know how to do that. We would divide by 5. And so we would get a mean of 10, right? We know that. That's kind of basic, right? Remember with variance, does anyone remember the variance formula? It's kind of a different one. I know it's going back. You're going to have this on your formula sheet. But just as a reminder, variance is, what's another word that relates with variance? Standard deviation. In fact, how do I get from variance to standard deviation? Square root. So this is just a heads up because we've had this a couple times. But the square root of the variance equals my standard deviation, right? We talked about that. But the formula for variance, right, would equal 1 over n minus 1. I love the Boy Scout outfit. Are you Eagle Scout?
Yeah.
There we go.
Certified Eagle Scout.
Certified. We have a certified Eagle Scout. You at home that are watching this.
I'm also an Eagle Scout.
Are you really? We have 2. The probability of that happening is very, very unlikely,
Out of,
right?
what, 7 kids in here?
Yes.
2 out of 7.
2 out of 7.
What's the proportion ratio? What's the proportion of the Eagle Scouts shoes?
That would. I'm sure it's very small,
I'm
right?
sure it's under 1 in 100.
Is it really hard?
It's just a lot of paperwork, really.
It's a lot of years, too.
And those of you at home right now, you missed a great opportunity on Grandparents' Day to have 2 Eagle Scouts in your presence at one time. Shame on you.
If you troop meetings, you can have 4.
Oh, wow.
Oh my god.
Oh,
Do you have
blow my mind.
Yeah, we're the troop at school. We actually operate in this room.
Oh.
Do you really?
Yeah, the flags. See the flags right there?
Yeah.
That's ours.
Where?
That's your flag?
Because
That's
you
our
didn't
flag,
know?
yeah.
I thought they
I
were.
did. I did know.
I thought he brought.
I did too.
You thought I just brought
Yeah,
random
yes,
flags?
I thought you had the
here.
flags
Oh,
in here
this
all
is-
last year. I thought they were.
I just never opened the flag. Troop 21, what's up?
Isn't Chad y'all's leader?
Troop 21. Do y'all have like a signal or something
Why did you in your
for like
uniform?
Troop 21?
Because I'm doing something like that. I'm not.
Yeah?
or just
Y'all
not-
should be.
yeah.
Y'all should go like this or something for like Troop 21.
No, we don't have a gang sign.
You have a gang sign. I never said a gang sign.
A troop sign.
But a gang sign, yes.
A troop sign.
This is true. Okay, so as we'll keep going. Okay, so the formula for variance would be 1 over n minus 1, and then we take the sum of x minus x bar squared, right? Which is each of the values subtracted by the mean. And so we're going to do that from the first to the last. Now, we could keep going through that. I hope you would know like kind of how to do it. A lot of this is done on our calculator. If you remember one variable statistics. But basically, just so that you remember what to do, in this case, we would do 1 over 4 times the sum of, which would be x minus x bar, so 4 minus 10 squared, right? And then what do? We say added, actually I'll take the sum out because I'm actually doing the sum right now, plus 9 minus 10 squared. Do I have to write all this out? Y'all get this? 10 minus 10 squared, I'll do it just so I've got it on the podcast, plus 12 minus 10 squared, plus 15 minus 10 squared, right? Because we're just taking each of these values and then taking them, subtracting by the mean, squaring them, adding together, dividing by 1 over 4.
I was like, where did he get 9, 10, 12, 15, 4?
Are
I
we-
started crying. I was like, where did that come from?
Oh, you mean up here, right? We're going. Do we get it now? You're like, Coach, you're just making stuff up.
I was so confused.
We've done this before, right? We've done this. Okay, so are we good? Are we good though? We're good on that? I was wondering, I was like, do I hear tears behind me? Is that-
I was so worried.
it was good. Good to go. So once I find that, I get 16 point, I think it was 16.4 is my variance. To find my standard deviation, what would I do?
Square it.
I would square root it to get like 4 point something, right? Okay, so that's kind of how I find my variance and all that. Now, here's the thing. With this, a probability distribution is just a little bit different, okay? To find my mean, and this is really what 6.1a is all about, finding mean variance from this. The only difference of this is as follows, and I want to, actually I'll come to the formula in a second. So the mean would equal this, 97. So again, we're going to still do kind of this same type of thing, except this time we don't have to divide or use the formula above. We're using 97 times what? 0.10. Okay? Plus 88 times what? 0.30 plus 80 times 0.60. If you remember, do you ever calculate your grade by hand and think, you've done this before because I know I hear it. This is what I have to make on the exam to pass the class. Like someone, and I'm like, that makes me feel great.
There's an online thing for that. They do it for you.
Oh, they do it for you?
I don't know where it is.
Yo, you don't ever do
I
that.
always do it by hand because it's sometimes it doesn't take into account the weights of different like
Yeah,
tests.
but
In
me,
order-
Tests
that's
and quizzes,
me.
it doesn't equally weighted.
So it's not exact there?
Yeah.
But I love it because I have people who will come into my exam this next year, hopefully not any of my AP stats classes, and they come in and they're like, Coach, I can make a 22 on this exam and still make a B in your class. And I'm like, well, that's great. I'm sure that you studied a lot for that exam there. But this right here is exactly what's happening on a basic scale, right? We're not taking all the other weights into account here. But what we're doing is we're finding the mean of these values. We're really finding our grade overall is what's happening. But we call that our mean. So we do 97 times 0.10, and then we just add what the value is multiplied by its probability that's below. Why do I not have to divide it by 3 here like I do up here? Why don't I have to divide this by 3 in a probability distribution?
Because
Because they're
is it
weighted.
97 already? Am I reading that?
No, that's exactly right. Yeah, so of the 10%, and Matthew and Maddie, you both said the same types of things, just a little bit different. This is like the average of my homework, right? And that would be the weight of that homework. So the fact that it's already weighted and the fact that it is the average of that specific assignment and it's discrete here, right? We can just say that the 0.10 multiplied by 97 would be like the average, like the weight part of that specific homework. So you have to divide this by 3, like you do up on top, right? So once we figure this out, the mean of this would equal 84.1, okay? So 84.1 is what the mean is of this here,
So
okay?
is that like your total grade, 84.1?
That's exactly right, yeah.
That's your 5 grade for this. Well, I guess since you're testing.
Yeah, because the test grade is weighted as 0.60, right? Yeah, I think that's traditionally what the grading scale is similar to. It might be a little bit different, but similar. Now, variance is, again, a little different, okay? Let's see if I can drop this here. Okay, let's do this. Let's do this last one here, and then the formula, if once I get this and I do an example, the formula is easy because you kind of just put that in a formula form. But within this, can anyone figure out what the variance of this would be, or the possibility of the variance would be? Okay, so it's the sum of what?
I don't know, 97.
And in fact, I'm not even going to put the sum yet, just so I don't confuse you. We'll do that in the formula. But what we would do is x minus what?
84.
Yeah, exactly. So what we're going to do is we're going to take 97, subtract 84.1, which is my mean, right? That makes sense because that was from our formula. What do I do after that?
Square it.
Square it, good. And then I multiply by its probability, the proportion there, 0.10. Okay, so that's this one. Then I'm going to add, same thing, 88 minus 84.1 multiplied by 0.30. Okay, and then I'm going to add the last one. I think I got 80 minus 84.1, square it, and I forgot to square that one, and then I multiply this by 0.60. Okay. All right, so really what we're doing, the only difference is instead of dividing by 1 over n minus 1, the weight that's already been calculated, that Matthew and Maddie both brought up, that's factored into this formula, and that's kind of, it's the same thing, kind of same type of thing. Does that make sense there? Are we good on that? Okay.
So why didn't we have to do 1 over n minus 1?
Good question. Within both of these formulas, is that why you're saying that? Because you'll notice, or this is 1 over n minus 1, right? And then this is like over n, we divide by it, right? Why do we divide by n minus 1 or divide by n? Because we're really finding the average, right? The average or the middle ground between these values, right? The mean of this. Over here, what is this? If you remember the definition of standard deviation in terms of some of our previous stuff, it's like the average error, right? The average distance each value is from the mean, if you remember that. So if we remember that, we always will divide by n minus 1. But in this, because we've already got the weights of 0.1, 0.3, and 0.6, we recognize the fact that that's kind of like the same thing as dividing by n minus 1. But the difference is this time, we can't divide by n minus 1 because each of the weights are different. Does that make sense? So that 0.1 and 0.3 and 0.6 is referring to that 10% of the data comes from here, right? 30% here and 60% on that side. Does that make sense? So probability distribution, just a little bit different, all right? Now these, this is just like the fancy way of just putting down the formulas. We've already done all of them. So with that being said, I think you pretty much could kind of guess where this is going. If we have the values up here and the probabilities here, what would be the formula for mu? This is the same as mean. We would just do what?
The sum of like your x value and your probability.
That's exactly multiply. Good, Mary Martha. So x1 times p1 plus x2 times p2, right? Times x plus x3 times p3, and then it's just dot, 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 right? All the way to x,
The sum of x times p.
yeah, xk, pk, right? Good, okay? And so we could rewrite this as the sum of x, I, p, I, which means, all that means is this. The I could be any one of those values, right? So the first one, second one, third one, and then what is this again?
Sum.
This means the sum of those values. So if you see that on your formula sheet, that's what it's referring to. Again, that's referring not just to traditional values, right? 5 different values. This is the probability distribution here, okay? All right, awesome. Now what about for variance? How could we do that?
Well,
It'd be the sum of what?
x minus the mean squared
X
times the
minus-
probability.
So plus xk squared
xi
Or xi
minus
x,
mu x
xk.
mu
or-
x or mu
Did
I.
you have to write the sum of xi times pi?
Wouldn't it
Let me
be
make sure I get that because I wanna
thought
make
it
sure.
was like the sum of
Yes.
xi minus mu x squared times the probability I.
You're exactly right. So if I were to go with that, Mary Martha, you were right with that. If I kept going, I would say x1. Now we could do it like up here, right? And I think Matthew, that's where you were taking it. Is it would be x1 minus x bar or mu, right? Because we haven't talked over the difference. Those are both mean, right? We would square it, right? Multiply by its p1, right? And then add, and then we just keep going, right? The only difference is that this one would be 2, okay? So does that make sense? So we do that for the first one, and then we would add the same thing except the second one would be here. So really what we're doing is xi minus x bar, or the mean. You said mu, which is fine. It's fine, the same thing. Times what? Probability of I, which just the I means that it could be the first, second, third, all the way up to how many ever I have.
Shouldn't the
And
squared
correct. I need to have that squared as the xi minus x bar squared times the probability, right? And then we would add all of those up, how many ever there were, okay? So if you see this, all I want you to think of is, oh yeah, that's exactly what we just did in the previous problems, and just kind of keeping that in the back of your mind for on your formula sheet there, okay? And what would be the standard deviation of this?
square root.
Just be the square root, right? So we would just take this and we would just square root it, right? And we would be good to go, all right? Okay, how did that feel?
Is that your face?
Yes, oh yeah, did you not see this? Look
Why
at
do you
this.
have the groove of the
I'm putting this, have I not showed y'all this?
Oh my gosh.
Watch this. Okay, I'm gonna erase this.
Why do
I
you have,
can't believe I'm putting this on a podcast right now.
yeah, why do you have the groove of the Hobbit in your face on Bilbo Baggins?
So what happened was I had a class that was relentless. Y'all are relentless a little bit. There's a class. When I say relentless. Like they would put my face on anything.
It was the seniors last year.
No, it wasn't. Well, they were
caught it.
too.
Oh.
They're pretty
Every class is
They caught
relentless.
it, yeah.
But no, there was this one class that I had taught for 3 years in a row because I just kept going up. And by the third year, they were seniors, and it was like the worst idea ever because they already were very comfortable and they were already like just giving me a hard time. I loved them, but they would give me a hard. So they would send me pictures randomly, and there was like me on Smeagol. I'll show you all that one later.
Oh no.
And then they sent this one and said something like, hey, coach, heard about that, you know, they got a new Hobbit coming out, and they sent it to me, and I thought, oh, that's cool. Like, that's a pretty cool, like, picture, because I was big into Lord of the Rings and stuff. And I was like, oh, my gosh, that's my face on here.
Bilbo Baggins.
And there was one guy in my class that would, he would he was obsessed with, he thought it sounds really weird on the podcast especially, but he told me that my wife was beautiful, kind of a little different. He was a little different there, and to the point where he cropped his own picture on my face when I was proposing. He got a picture from Facebook.
You have
And-
a lot of pictures on your Facebook. Though.
And cropped, I did. Yes, this is
no.
true. Of especially old
Like
pictures.
from high school with your sunglasses.
Oh yes, this is true.
Those are the funniest.
Oh, I was so weird in high school, y'all. I'm weird now,
Let's
but
find it.
I was weird in
It's
high
on
school.
there.
I think
So
that's
Yeah.
stupid.
But you're a good weird.
Good weird. This
That's
is true.
really creepy. Like,
Oh yeah, he would do that, and he was like, I loved having him in class. He was awesome, and I'm sure at some point, I don't want to say his name, especially on the podcast. I loved having him in class, but he would come up and do some things that I was like, oh man,
did
we
you tell
got.
your wife?
Yeah, I did. She was like, I don't know what to think of. Like, I don't know if I could like talk to that. Yeah, it would be really weird. But anyway, okay. So there's only one other thing before normal distributions I wanted to hit on. So I will tell you this: the notes for this down here. I can for the next class, I might just start on some of this stuff over here. But I did want to just kind of go from here towards the picture real quick and just kind of give you those notes real fast to have on the podcast and just so you have them there. This right here, remember a discrete interview? Oh, hold up. This is continuous, isn't it? Hold up.
Yeah.
I saw that. Made a big fancy trade yesterday because the guy with the
Poor guy.
Oh, hold up. Did I mess up right here? Oh, here we go. All right, discrete random variable has a blank number of outcomes with gaps. This is what we just did, right? Has a countable, right? So it's countable. Has a specific amount, right? I do, and I was gonna. We'll talk about this later. I actually do like one of my hobbies is like woodworking. Kind of weird, I know. I love it. I love doing it. Kind of one of those things. So I used kind of this idea of like if I sold wood furniture, right? Would that be a discrete or continuous variable, random variable?
discrete.
Discrete, right? Because I could, if I sold that, right? I only can do a certain amount. I couldn't do like 2.5. I could only like sell 2 pieces, right? There's no way. So no way to have. So it has gaps in between. So we say that that's discrete. Okay. So with that being said, I want you to think about this. If I had, based on the previous month, I know that I could have 0 pieces that I could sell, 1, 2, or 3 pieces, right? So that would be the values of x, 0, 1, 2, or 3. And the proportion or probability that I would have 0 was 30% of the time. So what would go in for here? 0.3, right? 1 piece that I sold would be 40% of the time, so that would be 0.4. 2 pieces would be 20% of the time. You get the idea. And therefore, this would equal 0.1. Remember that, just a heads up, that the probability of x, those values on the bottom, have to equal what? 1, right? And if it doesn't, it's not a, yeah, it's not legitimate. Very, very good. We talked about that the other day. Good math. Okay, so find the probability that Coach J sells at least 2 pieces of furniture. What would that be? 0.3, right? Because it's got to be to the right. So 0.2 plus 0.1 would be 0.3. Find the mean of x and interpret it. Well, how would I find the mean? Yep, 0 times 0.3 plus 0 times 1 times 0.4, my fault, plus 2 times 0.2 plus 3 times 0.1. And when I did that, I would get a value of 1.1, okay? So this down here would be, for B, 1.1. Could anyone interpret what 1.1 means then?
On average, you sell 1.1 pieces of wood per month.
Good. I thought it was discrete. How could I have 0.1 then?
It's just an average. It's not like you can't sell 1.1, but it's just an average, like an estimate kind of.
Correct. So on a given month, I could expect to sell 1.1 on average, right? That doesn't mean I will. It just means it's the average. That's exactly right. Okay?
So that's why when they're doing like baby predictions or whatever, they're like, we'll have like 2.5 babies born each week in the hospital.
That's exactly what they're doing. It's exactly what they're doing. It's very intriguing. You know what's intriguing about that, Maddie, is when we went to the hospital, they have it down to a science. Like where they'll say, like North Point is where we go. It's like one of the biggest hospitals for like carry and delivery on there. And when you go over there, they'll tell you, like in these specific months, on these specific days, they can kind of, based on the year and different things of when people normally get married, when they, there's a lot of factors into that. But it's kind of intriguing. And they can figure it out, a lot of them, based on statistics here. Probably a lot more complex than this, but kind of like that there. Okay? Do we know how to do the variance of this? We just did it on the previous part, right? I'll just give that to you. The variance would be 0.94, right? Okay, that's the variance. I'm sorry. Variance is 0.889. My fault. We square root it to get 0.94, so this is my standard deviation, right? How could I interpret this then? Standard deviation of 0.94?
Average distance away from the mean.
Average distance each value is from the mean, right? So some could be larger, smaller than others on a given month, but that per month, that's the average distance away it is from the mean, okay? Y'all rock, okay? This is our last one. This leads us into continuous, which is what we've already talked about. Here's just a little bit of a background, okay? And y'all go ahead. I'll continue to put this on here. This will literally be two seconds and we'll be done, okay? Awesome. Thank y'all for engaging. I know that was weird doing that with 6 people, but y'all are rock.
We felt like we were watching your performance for the podcast.
This is true. Hey, you already watched it, so you're good. You're good to go. So as we wrap this up, just those of us that are watching this, continuous random variable, this is different, right? This is like a normal distribution. If you think of a curve here, right? We've already talked about this, like a normal distribution curve that's there. But a continuous random variable is something that has an infinite number of outcomes. It has no gaps, right? If you think of a continuous curve, it can keep going to the right as well as to the left. It's continuous there, okay? If you think of x as the weight of a 3-year-old girl, that would be a continuous variable, okay? All right, so think of this here. See, Maddie, good day. If you think of like the weight of 3-year-old girls, it follows a normal distribution because you could be like 2.5 feet or 2.35 feet, or there are no gaps that are there. There's a wide range from from the shortest all the way to the tallest here. Okay, you could also do that with pounds in terms of weight of a 3-year-old girl, and so that's kind of important there when we talk about it. All right, so if we make a probability distribution of x, the problem is we can't. Okay, no, we can't. The reason why we can't is if you go back here, notice that within these values, we couldn't, if I had pounds, you couldn't have like 10, 20, 30, 40, because there would be values that would be between. So there's no way in this case, within a continuous random variable, that you would be able to have a probability distribution. We can't, okay? That's very important within a continuous random variable because we have infinite numbers with no gaps, okay? So instead of a probability distribution, this time we're going to go back to what we had talked about earlier, how we make a density curve. Remember, a density curve has a, like the area underneath, right, is equal to 1. If you remember, because all of the, underneath the normal curve, all of these, if we're looking at the probabilities of these within a normal distribution, it's anywhere from 0% to 100%, or 1.00. So kind of coming here, the total area, just to remind yourself, the total area under the curve is 1. To find the probability of x being less than or equal to 28, we just simply find the area under the curve, okay? All right? And as we look at both of these, we notice that the probability of x being less than or equal to 28, so let's just pretend that this is 28 here. The probability that, let's say we're talking about ACT scores or something like that, okay? And let's say that 28 is at this spot. The probability that x is less than or equal to 28, that'd be here, right? That is going to be the same thing. It's going to be equal to the probability of x being less than 28, okay? The reason why that's the case is because anytime the probability of x equals 28, that is going to be 0. So if you remember within, well, first of all, when you think of this, what is the probability that I will sell 3 pieces of furniture? Here we say it's 0.1 because it is a discrete random variable. When you think of something that's infinite or continuous, we remember that if I said what is the probability that x is equal 28, because it is infinite and it's not discrete and there's infinite amounts with no gaps, we say that a continuous variable, the probability of x being equal to 28, is actually 0. So in this case, we have to have something where it's either less than or greater than that specific value, okay? Also note that not all density curves are normal curves. That's important. I'm talking in terms of normal curves here, stating that, remember what makes it normal. Remember, normal means that it's 68, 97, and 99.7 percent within 1, 2, and 3 standard deviations away from the mean, right? And remember, standard deviations means it's the average distance each value takes from the mean, okay? So remember that when we talk about normal distribution and when we talk about that there. Okay. The only thing that I would say here, if I was to do one, I'll do one example just to remind you. You can also go to previous chapters here to check this out. But let's say that we have an intelligence score, one thing, and I'll do one of these and kind of go through it, and just so you have it on your notes, okay? Using the 68, 95, 99.7 rule, we're going to identify what percentile a person scores from 130. Now we remember that first off, it says it's normally distributed, so the fact that it says it was normal, we can use our normal curve and use our rule that's here. So we remember that the mean goes right in the middle of 100, and this is just, again, review here. 115 is there, and then if I subtract 15, this would be like 85, right? And then I could keep going to 130, and then this would be 70 right here, right? So what it says is what percentile is a person who scores 130. So if I were to draw this, and it's important that in any FRQ within a continuous random variable, when we do a density curve, specifically now a normal density curve, we are going to highlight that, stating that we're trying to find the percentile all the way from 0 to 130. Now remember that in this case, we state that these first standard deviation to the left and right hold 68% of our data, right? And then outside of 70 and 130, this is 95%. Which means that if I were to write this here, I would say that this value to the left and right of two standard deviations would hold 2.5% to the right and 2.5% to the left, because again, we're saying that outside of 95%, we have 5% here and here, right? So if I think about this, what I'm looking for is from that green line to the left. So if this is 95% from two standard deviations left and right, and 2.5s on the tails there, we would say that from this point to the left would be 95% plus the 2.5%, which would be a total of 97.5%. You could also do this by saying, what is to the right of it? Well, to the right of it's 2.5%. That means 100 minus 2.5 would be 97.5%. Okay? All right, so let's go back here. I'm going to erase this other stuff just so that you can kind of see what we've got over here. The next part says this: what percent of people score below, and this time I'll take a yellow color, score below 90. So if you think about it, 90 would be about right in here. And if I were to highlight, we're trying to find the percentile of what's in yellow for problem 2, right? So what percent of people score below 90? So we show a picture, and then the z-score. We got the picture up here. And we remember that z-score would be z is equal to x minus the mean, which is mu in this example, divided by its standard deviation. And that produces what our z-score is. And remember, we use our z-score on our chart that's there. So we have z is equal to x, which would be 90. And remember, when we talk about z-score, it's anything to the left of that value. So if I said over here, I want what percentage of scores were greater than 90, then I would be finding anything to the right side of that line. And so in that example, I would have to find the yellow, subtract that from 1 to get what was to the right of this. But because we said less than, we continue to go. 90 minus our mean of 100 divided by our standard deviation of 15. Our z-score produces negative 0.67. And when we have a z-score of negative 0.67, we're saying, remember, we could say Ella and A-Train, this is your job, right, with z-score. What is z-score? Z-score is the amount of standard deviations from the mean. So this is negative 0.67 standard deviations from the mean. So when we talk about like this problem here, we know, and by the way, just a side note, to denote normal distribution here, we'll say n 100, which is our mean, comma 15, which is our standard deviation. Okay? So that would be our notation, just so you kind of have a heads up there for this. It's important for FRQs to denote that there. And so I'm going to go to my my chart, right, and say where's negative 0.67 for normal distribution. I'm going to go over there, find negative 0.67 on my chart. When I do, I figure out that the area under the curve would be 0.2514, right? Which means that the percentile would be the 25.14 percentile. Okay? So what percentage of scores are below 90? We say 25.14%. Okay, or you could just put 0.2514. That would be sufficient too. Okay. You could also rewrite this by a calculator. And just a heads up, you can use your calculator for this too. Just make sure you show this. So I'll put, this is actually number 3. I could do the same thing by doing normal CDF, right? Normal CDF on your calculator. I believe it's the distribution on your calculator that's there. Normal CDF, the furthest left, we put a high number, so negative 9,999, comma, the furthest right would be 90. The 100 would be my mean, and 15 would be my standard deviation. So once I put that in for normal CDF, this would actually produce a very similar answer to 0.2514, and again would be another way to write this. But just be careful for my FRQ, I still need this picture up here, and I definitely need to put what's either in white or what's in yellow. The yellow is probably better to describe, but you could either do both. Just got to establish context. You've got to establish that formula there. Also, what you see here is important to also be included on that. So just a heads up on that going forward, okay? I think there's one more. Just want to make sure I hit on this. Number 4. We'll just kind of do that one real quick. On number 4, it says what score puts a person in the 99th percentile. So if we were to draw this out, right? Let's say we're trying to find the 99th percentile, which would be here, where at this spot, this is the 0.01, that's to the right of this value, okay? Remember, if I say 0.01 is my area to the right, okay? So 0.99 is the area to the left. What we're trying to do is go backwards, right? If you remember that this is actually, if you did inverse norm, you could find this on your calculator by doing inverse norm of 0.99, which is the percentile to the left of that value. Just be careful. Remember, we're talking to the left, so you got to adjust accordingly on your calculator if need be. And then comma my mean, comma standard deviation. Put that in your calculator. Again, it should be in the distribution part of your calculator. Plug that in, and the inverse norm of that would produce a value of 134.895. Remember, this is going backwards from what we just did. So to kind of continue with this on number 4, this time we're going to do something just a hair different. We're going to go to our z-score formula, x minus mean, mu, we'll call it, divided by my standard deviation. We don't know what the x value is, right? That's what we're trying to solve for. So we're just going to go backwards by going to my chart and finding what is my z-score with an area of 0.99. And that z-score was 2.33, which means that it's 2.33 standard deviations away from my mean. So I would say, okay, 2.33 equals my x value would be what we're solving for, minus my mean, which was 100, divided by my standard deviation, which was 15. So we multiply by 15 here. We're just going backwards from, again, what we just did. Multiply by 15 there, and then add 100. We would get an x value of 134.89. So notice that whether with my calculator or whether by hand, the big thing is making sure you establish context and go from there. Remember, too, to also put that my n, parenthesis, and then we put my mean, which is 100, comma, my standard deviation. This would be good as well. It also would be good to establish context. So if I were to talk about this, I would say, to finally kind of summarize this, the score a person, to put a person within the 99th percentile, that individual would need to at least score 134.89 or 134, I would just say 134.89 on the it was the ATT scores we were talking about, I think, on the IQ test, and then just go from there. So again, this is what we're referring to. This a lot was review. So if you're looking at this thing, Coach, that was a lot. Again, a lot of this was review, and I don't think it was extremely hard. We will review just a little bit to make sure that we're all good on some of this stuff for the notes and whatnot come Tuesday. But if you could check this out, make sure that you finish up that normal distribution homework as a review there. We'll get it done and go from there. Alrighty. Hey, care about y'all. Hopefully you have a great long weekend. Enjoy it, and we'll talk to you later. See y'all. Bye.